So derived units. So for example, for weight, okay, so the unit of weight is actually a combination of several units. The mass, kilogram, then you have meter per second squared. So in this particular case, we call this one as derived unit. So kilogram meters per second squared. Another quantity wherein the unit is a derived quantity is you can have, say, speed. Okay. So for speed, for example, the unit is not among, well, it is not listed among the fundamental units, but actually it's a combination of length, which is meter, and then the time. Okay, so meter per second. So this is a derived unit of length and time. So these are just some examples of derived units. We also have other derived units. Okay, so let's take this example here. Example number 1. 1 joule is a derived unit of energy. Okay, so joule is actually a derived unit. It's the same thing as weight. The unit of weight can be expressed not only as kilogram meters per second squared, but also as Newton. Or we use the symbol N for that. So basically, 1 kilogram meter per second squared is just equivalent to 1 Newton. So Newton is a derived quantity. So it's not a fundamental unit, but a combination of mass, length, and time. So same thing with your joule. So actually, a joule is a derived unit of energy. Because right away, I think you've learned this one in your science 10, that joule is a unit of energy. So when we use the unit joule, right away, we're talking about energy there. So potential energy can be obtained by raising an object above a base level. So as you have noticed, this is talking about gravitational potential energy. So if you're gonna displace the object at a particular height, a particular object can gain potential energy. And that potential energy is given by the formula mgh. So the mass and then acceleration due to gravity. So not g is not gravity, okay? It's acceleration due to gravity, which is given as the unit of meters per second squared, and height m. So what are the SI units for joule? Okay. So what are the SI unit of joule? So if you're gonna write out the formula for potential energy, it's mass times G times H. So what you're gonna do, if you will be taking the base units of each, mass is in kilogram. So it's just the same thing as multiplying kilogram. Acceleration due to gravity is given as meters per second. Again, because of the word acceleration, the unit of acceleration is meters per second squared. So that's meter per second squared. And then height is in meter. So if you're going to multiply everything up, you'll get a unit of kilogram, meter squared, all over second squared. Okay? So therefore, a joule is defined as equivalent to this one here. So therefore, we say that 1 joule or 1 J is just equivalent to 1 kilogram meter squared per second squared. Okay, so 1 joule, in accordance with our base units stated above, is a combination of kilogram, meter, and seconds. Okay, so same thing with weight. We can also say that using base units, 1 Newton is just equivalent to 1 kilogram meter per second squared. Okay. So this is just a quick review on your metric system.